My name is Gerhard Thonhauser. I'm the chairman and CEO of TDE Group. TDE Group works as a data-driven company and services the oil and gas industry. We have worked in the industry for now 20 years, so it's our anniversary this year. And we focus on essentially identifying performance gaps in drilling and soon also in production engineering, and then closing these gaps. Automation is like in other industries. I think it's a way of changing how people work, and I believe the hope that we have a radical change and suddenly you have a robot that drills wells is maybe too much of a step. So what you're going to see is a bit, in my view, like you see with the car industry. We are waiting for the autonomous car, but we're using a lot of assistance in a car for years that are part of such an autonomous car. A simple one would be an ABS, the braking support, or ESP that helps you to accelerate in a way that you don't leave the road with your car. So what I see is that in the drilling industry, it will be very similar, so that we're adding more and more, let's say, assistance that help the human, that move a lot of mundane tasks away from human work to essentially get more quality out of what the human can contribute, but eliminate a lot of the more awkward, mundane tasks that are easier to be done by a machine, essentially. I believe the main challenges are two. One is that for automation in general, and especially then autonomous systems, we will need another different quality of data that we have available to feed such systems. Now we're working in a very manual way, and the human is fantastic in kind of working with imperfect data. Machines have a huge problem. Now, of course, we hope that machine learning will help. At the end of the day, we will have to feed such systems with better information. The second element that is very important, we have to do this at cost, that allows in the aggregate to generate value. So if we automate for the sake of drilling a bit more expensive, I think it will simply not fly. So these two elements have to be balanced. Yeah, we have to be able to feed these systems. I'm sure we have the algorithms to do what needs to be done. We have the machinery, but we have to do this also at the cost that is creating value at the end. Yeah, there's steps in such a process that we believe we can support in a nice way. One is, first of all, we want to quantify essentially where the pain is. We want to quantify how much can be saved by essentially doing automation, changing the way you work, be it with a human in charge in the beginning or controlling the process in the beginning, being it in automation later. First of all, to address particularly the cost item at the end, you have to know what you can improve. So that is one of our core strengths. That's what we do with one of our products called Pronova for many years, and a lot of companies in the world, oil companies, service companies, contractors rely on very accurate information to quantify where they are. The second point is, then I addressed this before, is how can we get better data? So we identified one gap in the system, which essentially is, how can I get better data from downhole? Yeah, how can I make the downhole drilling system, the drill string with all the downhole tools, the fourth big component of the drilling rig that I can control like any other machine on the rig? Yeah? So that is the two gaps where we help. One on finding out where the pain is, quantifying the advantages. On the other one, closing a technological gap, linking the surface system with the downhole system with a technology called power line drill string, where you can communicate via the drill string. And we address the cost issue by having power from the surface for the downhole tools, which lowers the cost of running such a system, not only as a hardware aspect, but also by automating, then simplifying the processes, making the overall process of drilling, direction drilling, measuring much simpler and then saving costs from that. Yeah, innovation has been the motto of our company. I mean, we are a small company, and our advantage is essentially to bring new technologies, to innovate all the time and stay ahead of the game. So where we see advantages is essentially in more cost-effective ways to collect data. This is where we're working very hard. Then in, like I mentioned already, in technologies to close certain data gaps where you cannot measure or communicate in an adequate way today. And the rest of the innovation, having the data, really is tied to using physics like classic simulators, and for us very much in combination with what you call machine learning, artificial intelligence, to say how can we use the data that we have to improve, to be predictive in terms of prognosing problems coming up, in avoiding problems, and at the same time having the machine in combination with the human that will still be in charge for a long time, I believe, working in an optimum way. So all our work in terms of creating innovation goes in that direction. How can we capture know-how? How can we capture the best way of doing things? And how can we bring this to the field? I think there's two aspects to this. One is that the whole automation and data agenda, is something that we can support with the solutions and products we develop, not only in products, but also in a very open discussion what the pros and cons are, like I tried to allude to. So there's no silver bullet that solves everything. So I'm hoping to engage in a lot of discussions with other colleagues in the industry. And then, of course, we want to show some of the solutions that we have, existing ones that we have on the market for many years, but also new ones like PDS that I mentioned, showing the potential of this, showing what a sensing downhole connected to the surface can do, what a long string measurements can do. So we want to share some of the new things that we're doing and find out whether we can get excitement in the industry for it.